Assalamu alaikum and good morning. Today, Dr. Shaila from Yes, I'm Norway is going to discuss something with a very beautiful person in my life, my teacher, my supervisor, my mentor, Professor Hallvard F. Svendsen. He had been, as I said, that he had been my teacher and supervisor and my mentor, my friend, like my father, elder brother. So many things I will be talking about him. But before going into that detail, I want to thank Holbert that he's with me early in the morning on the Valentine's Day. First of all, happy Valentine's Day to all of you and us as well. And I will take you to Professor Holbert F. Svendsen. He will tell about himself. Hello, sir. How are you? Good morning and welcome.
Good morning, Sala. I'm fine, thank you. Hope you're the same on this Valentine's Day. So, as you said, I'm a retired professor from the university in Trondheim, NTNU.
Professor never retires.
Pardon?
Professor never retires. So you are.
No, true. I'm still working. So I'm trying to go down to the university a few days a week and chat with the PhD students and hopefully do some useful work as well. Yeah.
That's great. So nice of you, sir. How are you doing nowadays? You are looking so young and fresh, mashallah. Mashallah is in Arabic. And what are you doing? Before going into hardcore questions and things like that, I just want to take a slow start by saying this with these compliments that you are looking very nice and young today.
Well, thank
But
you for that. It's maybe not so nice, but okay. As I said, I'm trying to do a little bit of work, and since I've been working with CO2 removal, CO2 capture for a couple of decades or a little bit more than that, together with you, among others, I'm now concentrating on that and mainly on the problems of aerosols in absorption columns can cause emissions. And this is something we definitely do not want if we want to install large-scale capture plants around the world in order to help the CO2 problem that we have with global warming and, all of that. So that's my main concern for the time being.
wow, it really sounds great to me. You know, Holbert, I had a PhD subject during my PhD that was combustion atmospheric physics,
Mm.
and there was an assignment, and I worked on aerosols. My PhD assignment for aerosols was there, and
Okay.
I did a lot of work on that when I was doing that, and it really sounds great that you are working on aerosols now.
Yeah.
And that is really really nice to know. Okay, since you have shifted yourself to aerosol, we'll talk about aerosols as well. But before that, I would like to talk about carbon capture and climate change, which we had
Mm.
been working with 10 years,
Mm.
12 years ago. So for me, you have been like a pioneer in the business. And I do remember that when I was in Pakistan and I was applying for masters, you were the person I wrote a mail that I want to work with you in your department. And at that time, you didn't know me. I didn't know you. I just gone through your profile and I said, okay, this is the person I would work with. And I worked with you and I am honored. And that's the most beautiful time of my life. So, what do you can you summarize something about carbon capture, the carbon business, and everything? Kya khoya, kya paya in Urdu means pros and
Well, the, I think it's very difficult to summarize in a few words because it's such a vast subject. But when it comes to CO2, it's one of our age's, I think, greatest problems because it gives us the global warming that we're all feeling. Also here in Norway, we're feeling the global warming by more harsh weather, I would say, storms and increased precipitation. Other places in the world feel this much more because of sea rise and things like that. But when it comes to CO2 capture, there are several technologies, as you're aware of. We can use membranes to remove CO2 from off gases from industry, from energy producing plants, electricity producing plants, and such. We can use absorption as a technology. We can use adsorption as a technology. There are many different ways to going about this. And what I've been working with is probably the most mature technology that we have today, and that's absorption with chemical solvents. That means that you have a solvent which will actually absorb, take up the CO2 from the gas that you combine it with. And then you release this gas by just reversing the reaction using heat. And then you can produce relatively pure CO2, I would say quite pure CO2 and water. You condense the water and you have CO2 that you can use for nutritional purposes, or you can store it, which we have to do because since the world now is producing around 40, 50 billion tons of CO2 per year,
Huge.
There's no way we can use all of that CO2. The annual use of CO2 is approximately 500 million tons, so it's a 1% of what we produce of CO2. So we have to remove the CO2 and store it. And the store that we have available to us is underground storage in aquifers, for instance. There are other ways as well, but aquifers seems to be at least the best way of storing.
And
So
Norway is lucky enough to have many aquifers.
yes, it is. Offshore Norway, we've had a plant, or it's actually a production plant for oil and gas, Sleipner plant. It's an offshore field, and there they have captured about 1 million tons a year for now nearly 30 years, which they have stored in an aquifer below the platform or above the oil gas field, and it's about 1,000 meter deep. So, and this has been monitored throughout the years, and there's hardly any leakage. They haven't detected anything serious there. So I think this is it's a viable way of actually capturing CO2 by absorption and storage. Of course, whatever method you use for capturing, you can still store it. Doesn't matter.
Okay, but Hallvard, when I was into the business and in the conferences, I had been listening to people that nobody wants CO2 dumped under his or her lawn, so people are against this sequestration thing. And then China comes in business, and they have introduced the idea of carbon capture, storage, and utilization, US things. So how far they are? Have they developed some more technologies? Like, for example, I was going through a report, Juliana, she had been working on cement things that if they can absorb CO2 somewhere in the in minerals, and then she concluded that it's not a viable things, or maybe things like that. I don't remember exactly. How far is it when it comes to the utilization of carbon dioxide?
When it comes to
that story?
Yeah, it depends what you mean by utilization. As I just mentioned, the use of CO2 today is approximately 500 million tons per year. That's what we use in chemical processes, and where we produce the CO2 maybe from virgin sources, or we can capture and reuse the CO2. But since I was talking about storage, that's because the remaining 49.5 billion tons of CO2, we don't have any use for it.
Yeah,
when people are talking about utilization, they're talking about using the CO2 to produce fuels, for instance.
Yeah.
And one has to remember that CO2.
Fertilizers as well.
Yes, yeah. One has to remember that CO2 and water are at the bottom of the energy chain.
Yeah.
We have exhausted all the energy that is in the carbon when we produce CO2. So that means that if we want to produce now, say, fuels, liquid fuels, or any other fuels from CO2, we have to add energy. We have to use energy to produce this. And then you might ask, why do we want to produce these fuels? Because we could use the energy otherwise. Depends in what form do we have the energy. The only situations that I feel is where it's really worthwhile to produce a liquid fuel from CO2 is when you have sort of isolated energy sources which you cannot use for any other purpose. It would be in very remote areas where the transportation of the energy would be very costly. Then you could think of producing something from the CO2 if you have CO2 available at that spot. That you have to have as well.
Yeah.
Otherwise, I would say that if you, for instance, there has been suggestions to produce hydrogen by electrolysis and then combine it with CO2 to produce some fuels of different kinds. But if you produce hydrogen from electricity, you already have the electricity. You lose energy efficiency in every step which you take. So in my head, at least, we have to use as few steps as possible before we use the energy. If you have the electricity, that's sort of the ultimate form of energy we have.
Yes.
So it's electricity has the disadvantage, I would say, that it's a little costly to transport. The energy loss when you transport electricity is relatively high compared to transporting oil or gas in pipelines, for instance. But that's the only disadvantage that I see of electricity. So when you have, we're talking about hydrogen for cars, but if we produce hydrogen from electricity, why not have electrical cars, which we have already?
Yeah.
So I'm a little bit
skeptical
when it comes to the utilization part, apart from, of course, substituting virgin CO2 by captured CO2. That we should do for all the CO2 that we're using today, and uses that we see are viable in the future as well. But large-scale use of CO2, as I said, the remaining 49 billion tons, I don't see we have any other choice than storing. We have to store.
That's true. Okay, when it comes to hydrogen and even water, we are talking about energy batteries, because the world is going to be shifting towards renewables, and we have to store something somewhere, energy. So there are water reservoirs, pumped water, so we can reverse it and we can reuse it. Then hydrogen as energy battery. Then CO2 can be used as energy battery. The minerals. So one thing is that you can produce, you can harness energy, and the other thing is that we have to store it. And storage, we can use anything which is viable, because it's not only the energy produced, it's its distribution, its handling, and which one is the cheaper one, either in the form of hydrogen, and then hydrogen have so many other things. So actually we are not going in those things, otherwise we will be just caught there. I will go to my next question regarding CO2 capture. That what do you think that in the carbon capture business, or in the whole chain, what is the biggest challenge today for the adoption and economic viability of any carbon capture technology?
Well, as you indicated, we have to have the whole chain.
Yeah.
We have to have capture, we have to have transport, and we have to have the storage part. And if just to take an example, we have this Northern Light Longship project in Norway, where there's a hub on the west coast at Øygarden, and where they plan then to store this CO2 using a pipeline from Øygarden into the Aurora field. You probably know all about this. But the problem here is how to get the CO2 to the hub at Øygarden.
Yeah.
The hub is already there. It started up in September, October last year.
Oh,
And I think they have already some contracts in the Netherlands with about 800,000 tons per year. And they have they're planning on ship transport, as you probably know, from Breivik, the cement factory at Breivik, the Heidelberg cement factory, where Aker is now finalizing their capture plant there. It will be finalized, I think, this spring. And there they'll produce or capture about 350, 400,000 tons per year, and then transport it by ship to Øygarden before it's compressed and then stored in this Aurora field. So, but I think it's the chain concept. You have to have all of the parts of the chain in place in order to do this. And if we look,
definitely,
yeah,
all in one picture.
Yes. So, and if you look at the transport part of it, ship transport over long distances will be rather costly. So if we're talking about relatively long distances, we have to have pipelines. And as you indicated earlier, nobody wants a pipeline in their backyard. For some reason, they want or they will accept a pipeline carrying natural gas, no problem. If you look at gas distribution in Europe, everybody has a pipeline in their garden. But CO2, which is much safer, which shouldn't be a problem at all, that's not acceptable. It seems, but maybe it will be acceptable. But we have to use pipelines. I think mobile transportation by cars and ships and things like that will be rather costly. So, but when we look at hubs on the continent, for instance, there's a hub being planned in Rotterdam. Then we'll have a pipeline from that hub to some of the fields in the North Sea, whether that will be a depleted gas field outside of Netherlands or an aquifer somewhere else. That remains to be seen, but then we'll have a good transportation system. And of course, we can use disused gas pipelines. That's a possibility that has been looked into, and it seems that it's possible to, if they're not totally destroyed, that it's possible to also transport CO2 in them. You know, we have a transportation system in the northern part of Norway at Melkøya, at Hammerfest, where they transport about 700,000 tons of CO2 by pipeline into the Snow White aquifer outside northern Norway. I don't remember exactly the distance there, but maybe something like 100 kilometers, 150 kilometers, something like that. So this is possible, and when you talk about pipeline transport, it's not that energy costly either. So it's definitely a possibility.
We have transport phenomena in work, so no problem. Our fluid dynamics and transport phenomena lessons, they will be there to help all the engineers. Thank you, Hallvard. Actually, I have so many questions, and I would be listening to you for hours and hours and hours, you know. But you have limited time, and I want to ask all the questions I have. So there are many startups and there are different companies. They are working on direct air capture. People are talking about it. Today on LinkedIn, I saw one of my students. He's in UK. He gave a lecture on direct air capture, and I am also interested in it. So, what do you think about direct air capture, and means how can it work?
Yeah.
How do
Well,
you- something like that?
if we look at the problem thermodynamically, I mean, whatever method you use for the capture, whether it's membranes, absorption, adsorption, the less CO2 you have in the gas, the partial pressure or the pressure of CO2, the smaller that is, the more difficult it will be to capture it, and it will be more costly.
You are on the point when we were discussing my PhD project in 2010.
Yeah.
There are plants. They have higher concentrations. We should concentrate on them. But go ahead.
Yes, that's what I'm hinting at there. That I mean, in air you have now. Well, it's been increasing, but you have 400 ppm, a little bit more than 400 ppm. Of CO2, which is 0.04 kilopascal for those who are into those units. So it's and if you talk about gases from industry, from natural gas-fired power plants, which has the lowest concentration of CO2, you have about 4% of CO2 or 4 kilopascal. Then you go up to maybe 12 for a carbon-based power plant, and for industrial purposes or for off gases, you have maybe 14, 15, up to 20% of CO2. So you have much higher concentrations, and for some of them also higher total pressure. So that means that the pressure of CO2 will be much higher, and the higher the pressure of CO2, the less costly it will be to capture. So with the extremely low pressure that you have in the air of CO2, I think it will be rather costly. And in my view, nature itself is the best the best source of capturing CO2 from the air. The biomass, we have trees, we have all the biomass in the sea. I think maybe 60 to 80% of all the CO2 bound is in the biomass in the sea. So of course, using that, and then well, if you burn biomass, you can get higher CO2 concentrations. You get the energy, and you get higher CO2 concentrations, maybe 15 to 20%.
Jesus, Hallvard.
And then, of course, you can have what we call a CO2 neutral system, or a CO2 negative, even in some cases.
About it, That's perfect. It sounds great. Okay, the next question is any breakthrough in materials and solvents you had been working, or other people are working? Anything which we said that this is the optimum one?
Yeah, it's difficult to say. If you think about sort of what we call a quantum leap, which is really a small one, but it's usually used as a big one, there hasn't been really any big leaps in when it comes to new solvents. We have a steady development in the solvents, but if we look 20 years back, it's not. I mean, we have gone maybe. We have reduced the energy cost by 1/3 approximately, which is considerable, of course, but it hasn't been more than that. But I think that what we can say today, and even 20 years ago, the technology for capture with absorption was ready, and it's ready today, but it has developed, as all industrial processes will, and it has become more mature. It's better. It's more energy efficient. So if we look at if we take just an example, natural gas energy producing, electricity producing plant with CO2 capture can today operate with an energy efficiency of approximately 60%, which is really high.
This is
It's really high. And I don't know, maybe you will come back to this a little bit later, but if we look at the land use and compare this with windmills, and so on. I mean, it's a huge difference. If we have a 400 megawatt plant with CO2 capture, maybe 0.5 square kilometers, 0.05 square kilometers, 0.01 square kilometers, something in that range. Whereas you would use 100 times more if you're producing the same amount of electricity with windmills, even in a good location.
Yeah, it is.
Even in a good location.
Windmills are huge, and they take a lot of energy, and they have their own pros and cons.
Yeah, if you look at the energy efficiency in air, I mean, the density of air is low, so the energy efficiency is really, really low.
That is, of course, and that is understood for all us chemical engineers that how it affects. That is true, Hallvard. Thank you very much. Okay, there's a debate like carbon capture is just band aid to allow the continuous use of fossil fuels. Okay, we admitted that it's for the transition period, but do you think that what's the future and the people in this business, carbon capture and things like that? How far you can see that it would be working?
Well, to go back to what you just said, a band-aid, you need a band-aid if you have a wound of any kind for some time.
Yeah.
And I mean, there's a saying that the best is the enemy of the good. And I think in this case, capture is a good thing, and we have to utilize it for the time that is needed. Pardon?
I must add, I want to detract you. We are carbon capture people. That's why we are biased towards carbon capture.
That could be, but what is the alternative? I mean, if you look at the development today, where we have hardly had any carbon capture implemented, the amount of CO2 that we're releasing is going up all the time. Of course, I would say that just to not counter, but actually support what you're saying, that what we should do is to save energy.
Yeah.
We should save energy and thereby reduce our footprint when it comes to CO2. But as it seems today, very few people are willing to do that.
Yeah,
and the politicians are becoming more and more populists.
Yeah.
Well, we don't have to go far to see that.
Yeah, they simply say that who are you to regulate our thermostats and our cars and our lifestyle? Who are you? Even in Norway, Hallvard, we are culprits. We are among the biggest users.
The worst, yes, we are definitely. I know. Yeah. So there has to be implemented a system, I think, where we pay for our releases, whether it's CO2 or other emissions to the air or to the water, for that matter. Whether it's plastic or CO2, it doesn't really matter. We have to be we have to pay for it. We have to be aware of what we're doing and not just releasing all the things we're doing now.
That's true. Okay, Hallvard, what do you think that what's the role of Norway in global carbon capture? And although you have already discussed different projects going on in Norway, how do you see? Are you satisfied with the role? Do you want more, or is it more, or what do you want to say?
To be honest, I'm really relatively disappointed with the Norwegian policy at the moment, because it seems that the Labour government that we have, they're not really eager when it comes to CO2 capture and to reduce our emissions. They have just opened up 53 new licenses for test drilling. So I mean, I don't really like this. I don't really like it.
After listening to this from you, I can think about changing my political affiliations. I am affiliated with them, But yesterday
Yes.
we will discuss that what did they discuss, and I am not happy with that.
No.
We can discuss.
So,
We will discuss later.
whether
Okay,
I was
we can discuss it right now. We can discuss it right now because
yeah.
yesterday, as I told you, I shared with you the pictures of their presentation.
Mm,
They are talking about nuclear power,
mm,
introduction of nuclear power after 2027, because they think that now we are surplus in energy production, but till 2027, instead of surplus, we will be having lesser electricity production as compared to our demand. So we'll
mm,
have to think about so many other things. And they had their own presentation, and there were two presentations, and they were talking about that in the energy scenario, how oil is depleting, and there are the problems related to renewables and things like this. Okay, I admit that nuclear power plants as an alternative fuel, just like as carbon capture as a band-aid, can help. But as I think and I look at the world, my world, it should be totally on renewables, and we have to work on those.
mm.
I don't know how, but this is how I think. But when Norway, I had been idealizing it so much. And if they are talking about nuclear power plants, what do you think, Albert? What's going to happen, and why are they thinking like that?
Well, I I don't know why they're thinking about that.
Please.
They have to answer themselves. But I and I, as I said, what we have to do is to save energy rather than just look at the foresight and of the electricity producing companies. They want to sell energy. We have to save energy, and when it comes to nuclear power in Norway. Uh, it might look good in some ways, but there are several, I would say, obstacles or problems with nuclear energy. One of the problems that you have initially is that if you go for uranium as your source, there's a limited amount of uranium available. So I think that if you were to really have a large-scale nuclear power system in operation, you have to go for other minerals, like thorium, for instance, which has been proposed. And I think if we could have reactors based on thorium, maybe the problem of source material at least would be solved. Then, of course, you have the problem of the waste material.
That is the
That,
problem. It's
that's a
that is
huge problem.
what?
The only country which has really faced that problem and done something to counteract it is Finland in their new power plant in mid-Finland, which is a huge power plant, 5,000 megawatt. They used 20 years to erect it. And at the same time as they erected the plant, they built underground caverns in a stable stone system where they can store the waste material. But as far as I know, it's the only country that has really taken this, well, maybe seriously, but at least they have a system where they can store this. The other problem is that when the Norwegian government is talking about nuclear power plants, as you said, they're talking about after 27.
Yeah.
But there's no way that there will be any nuclear power plant in operation in Norway by 2027, even if they started building today.
Yeah,
It
no,
will
no,
it will take it will take much longer. It will
start in
take much longer.
27. They had a plan for from 27 to 2060,
Mm,
like 35 years.
mm.
But I don't know what are they up to, and why are they thinking like that. Maybe you guys who are in the business,
Mm.
or if I would be given a chance,
Well,
I will be thinking.
I must say I'm quite skeptical, but if they're thinking about it, they also have to think about how to store the waste materials. They have to have a solution for that.
That is the biggest problem, the
Mm.
waste.
And also, if we look at the cost factor, nuclear power is quite expensive.
They claim that
It's not cheap.
and I'm not sure how did they calculate it that this is going to be the cheapest one. I don't know what's the technology they have in their mind. They were just talking, since it was just a political thing, just a brief scenario. And I would be looking into the matters. I will ask them how, and this I will use my PhD and
Yes, I should absolutely do that. Yes.
join me, and then I will be speaking.
Yeah. But if you look at Sweden, there they have, I don't remember exactly how many, but maybe 4 or 5 power plants, nuclear power plants.
They're rapidly shifting themselves towards wind and biomass.
Yes, wind. If you have good places for wind.
Yeah, of course.
I mean, you what you do not want to do is to destroy nature that you would like to have there.
Yeah.
You would like to place them in places where, well, you have other things that so it doesn't really matter. But then you say you face the problem that maybe this is not the best location when it comes to the energy efficiency of the windmills. Maybe it's not the most windy places that you have. So then, of course, you have the offshore windmill production, the ocean windmill energy production, which is relatively costly because the production, or placing the windmills offshore will be rather expensive.
Yeah.
So I just recently saw that in Norway, where there has been a large, I would say, pressure to have windmills offshore, they now say that this is too costly, so forget it. I don't know whether this is just another political bargain or whatever it is. I think still the windmills offshore is a good option, but it may be expensive.
That's true. Okay, this energy question just came due to our weather party. Otherwise, it was not a designed one. And thank you very much for answering this. Now coming back to our carbon capture business, which is still going on. If you were to design a perfect carbon capture system for world today, what would it look like?
That's difficult to tell. I mean, as we said, you have many technologies
Your favorite. I know your favorite, but
yeah.
You tell me.
Yeah. No, I would of course go for absorption because it's the mature technology that you have today. It has the disadvantage, I would say, that it utilizes liquid solvents, and potentially you can have emissions of these amine solvents that you're using today. But I see that in newer test plants, large-scale test plants, we're looking at emissions in the range of maybe 1 to 10 ppb of amines in the outlet gas, the exit gas. So if this is the case, if we can operate in this range, 1 to 10 ppb, I don't think that there will be any problems with the release of amines, because amines in the atmosphere, they can form nitramines, they can form nitrosamines, but at least nitrosamines will be broken down by sunlight relatively quickly. And the amines themselves will be washed out by rain, and I don't think they will do much harm in the environment once they're in the environment around us, because the quantities we're talking about then will be very, very low. So I think that this is one way. But if you think of how many plants we have to have, then the numbers become a little bit more frightening, I would say, because if we're talking about capturing something like 40-50 billion tons of CO2. As I said, at Sleipner, we have a plant that captures 1 million tons a year. We have to have 50,000 of these then.
Yeah.
So the numbers become very, very large.
than
So
the,
it's I think it's a little bit optimistic, if we put it that way, to have that number of plants. But we can do our bit at least when it comes to capturing. So I think that we're back to starting to save energy. We have to save energy.
that's true. I had been teaching renewable energy resources in a Pakistani university. It
Mm,
was online, and I had been talking about energy conservation first of all.
mm,
And there are different studies going on. Up to 40% of energy can be saved just by energy conservation, by using better lights, better
mm,
fans, better heating, cooling systems,
mm.
just changing a little bit of your thermostats and changing your habits.
Yes.
But we being human being, we are not ready to give up anything on our part. And then we say that, oh, what's going on?
Yeah.
And
We're lazy.
we are lazy. Yes, we are. And we are selfish as well.
Yeah.
Okay, Hallvard, coming back to NTNU. You had been working there. You have spent decades of your
Mm.
life. And what key advancements you have observed that chemical engineering department at NTNU has made during your scenario or your timeline or your time frame?
Well, it has changed quite a lot. I mean, if you go back 40, 50 years when I had my education in the 70s,
Mhm.
uh, then of course, or actually in the 60s, uh, I, I started in
Don't know very about your age.
66, so it's quite some time ago, 60 years ago soon. Okay, anyway, there was a lot of focus just on what we call unit operations in chemical
Yeah,
engineering. That was sort of
particle
the thing.
technology and gravity and heat and mass transfer.
Yeah, yeah, and that's important still. I would
Yeah.
say heat and mass transfer is definitely very important.
Yeah.
But the focus is not so much on these unit operations any longer. It's more on the, I would say, the basic mechanisms like heat and mass transfer, which are basic mechanisms. And you had one question, I think, also on transport phenomena, which is part of this, of course,
Yeah,
and
I'm very
the theory behind that, and how to use this in order to improve the operation of plants that we have today, the design of plants, uh, like for instance chemical reactors. I mean, one of the problems in chemical reactors might be heat transfer, to remove heat or to
impressed.
transport heat into to the reactor. And of course, mass transfer, if you have multi-component reactors, you have mass transfer problems. Then you have, after the reactor, one of the most energy demanding things are the separations after the reactor system. You have to separate whatever comes out of the reactor. So if you can combine reactors with separation systems, which is now, I think it's one of the research areas that are really being focused a lot, how to combine separation and reaction chemistry, so
Wow.
that you can avoid all the cost that is associated with separating the reactant that you get out of a reaction system. So you could do that. So yep, this is one of the things, and of course we have seen a tremendous development in computers
Mhm.
and well, AI as of now.
Yeah.
As I said, I started in '66, and what we had then was a slide rule. That
Mhm.
was our computer.
Yeah,
So things have developed quite a bit since then. And
that's
then you of course you had the handheld small computers, and then you had you had the PC now and everything. So it has changed tremendously, I would say. I'm
it
a
has.
little bit I'm a little bit scared when it comes to AI, but I try to use this chat GPT a little bit.
Okay, congratulations.
not a lot, I must say, but and I've tried to use it not only to prepare a speech for a birthday or anything like that, which I think it can do very well in general terms, that is, but to try to use it in my field, like absorption, and what it gives is almost nothing. There's hardly they're general terms.
Of course,
Hardly any substance behind
that
it.
is true. Actually, ChatGPT is for those people who just want to give you some surface things. That's good for them. If you are expert in absorption, how ChatGPT can compete with you, Hallvard? Even me, it cannot compete me. I am nobody in this business. But I am better than ChatGPT when it comes to my own subject.
Yes.
But for a general thing, for a quick review and just to summarize things, it's a good tool. But we can never rule out the possibility of the human mind, intellect, and our own emotions and our care and everything. So they will compete us, but they will never compete us.
Let's hope so, at least.
That is true. ChatGPT can impress people with little or no knowledge. But who has some in-depth knowledge, ChatGPT is nothing. Okay, then my next question is about students. I'm coming back to student life. What misconceptions do students or young researchers often have about transport phenomena? It had been one of your toughest subjects, and I have seen people failing it again and again and again. And you, I don't know, you had been very hard, tough teacher.
You say so? I don't think so. But
for me, it was not.
No.
I must say, Hallvard, that just it's my fan moment. Although I wrote an email to you before coming to Norway when I was in Pakistan that I want to work with you. But the moment you came in our transport phenomena class, teaching us transport phenomena, I fell in love with you. You are so nice. You ask a question, and I used to answer. And whatever the answer is, it's not only about me, it's about everyone. You never said no. You said, yeah, you're right. It can be like this. And you understand like this. And that is, I really admire about you, being your student, that you never said no to any answer given by me or anyone else. If we said something, you said, yeah, this is correct from this way. This is correct from that way. And this shows your in-depth knowledge, first of all, and then you are multifaceted. You have all the dimensions. That's why you were able to grasp everything. Otherwise, there are teachers who say, no, I like this answer. You did not give the answer which is in my mind, so this will not work. So you were different. For me, you were nice.
Thank you.
Itself is not an easy subject. I confess that.
Yeah, it's I'm happy that you felt that way. I'm happy that so, but it's been some time since I was involved in transport phenomena classes. You know, Hugo has taken over the classes there, so he's doing.
Is he teaching now?
Yeah, he's been teaching for, well, I retired 10 years ago now, so he's been teaching this for 15 years, something like that.
Transport phenomena at NTNU is taught by Hugo now. Wow, that's great.
So, and he has written a book about chemical reactors and transport phenomena.
Wow.
It's you know, Bert Stuart Lightfoot book, Transport Phenomena. But this book is double the size of that one.
He's fond of writing, you know, just remember, I do remember his PhD thesis. It was like this much thick. So I will talk to him.
Yes, you should. Yeah.
I am.
You should.
I'm following him on LinkedIn.
Okay.
We are on LinkedIn. I will talk to him. Yeah. So thank you for telling me. I would be talking more transport phenomena with Hugo now.
Yeah.
That's great. That's great. Okay. Yeah. So what are the misconceptions?
Well, as I said, it's 10 years since I retired, and that means I haven't taught transport phenomena maybe in 15 years. So I'm probably not able to tell what are the misconceptions today. But if we go back 15 years, I think that it's as with mathematics for many students at the lower level. They think it's so difficult.
It is.
And if you think it's difficult, you have a tendency of blocking your mind to it. And I think that could be the case also with transport phenomena, that many people think it is really difficult. But it really isn't. It's like mathematics in a sense, part of it at least. It's you can set up equations that in basically should be correct. Of course, there will be empirical equations coming along that where you're not certain, or you know that they're not 100% correct. They have a certain uncertainty, and but you have this mixture of and I think chemical engineering in a sense is this mixture of certainty, where you have the mathematical concepts that you know are correct. You have the physics that in basis are mostly correct, and then you have the empiricism that comes on top of that, which
Hallvard, I must add here that most of things, even in our mass transfer, heat transfer, if we talk about convection, for example, especially forced convection, we don't have a single equation.
No.
It's dimensional analysis which is coming in the picture.
Yes.
So there are so many things which are unanswered, and no certain things are there. Even the JH factors in heat transfer and then in mass transfers were so difficult things. I don't want to go into details, but it's always a combination. And then experiment, and then your own innovation and imagination. Because transport phenomena, you can never like transport phenomena if your brain is not imaginative. You have to imagine things. If you can imagine, then you can develop an equation, and then you can write it down. Equation can be right or wrong, or must be working, not be working. But at least if you are imaginative, you can have an idea. So imagination is the key here.
Yeah, and I think not blocking your mind, not saying that this is too difficult for me. I won't understand it. That makes it impossible for you to really grasp what it's all about.
That's true. Maths involved in transport phenomena is really difficult. It is difficult.
Yeah. So it's like having an open mind to everything, Maybe capture from air.
Yes, capture from air.
Even though that's difficult to be open-minded about.
Okay. Then coming towards chemical reactor technology, it's, as you said earlier, it's the heart of many industrial processes. And what are the most exciting developments in reactor design right now at our department, our chemical engineering department?
I think, I'm not sure I'm the right one to answer that, but I think that it's a little bit what I just said, that you have this mixture of separation and reaction. You combine the things, and the chemical engineering department has gone a long way of establishing research areas in biochemical engineering. So they work with biochemists, and they have the biochemical engineering part, which is now a strong field in the department. So that is a development that has taken place now over 15, 20 years. I think we've been going in that direction. And one thing that has been resurging in our department is hydrometallurgy. I did my PhD in hydrometallurgy in the 70s. On solvent extraction. Yeah, and now it's back again, and of course one of the focuses is lithium, because we use lithium in the batteries. and lithium is not a scarce material really. Lithium you find in many areas or many places, but it's in very low concentration. So what we
How
have been,
I got goosebumps here. Lithium is the battery, the energy battery, the real battery, and
yeah.
you are spot on. Actually, you are.
So I wouldn't say I'm supervising, but helping a little bit in a PhD who's working on recovery of lithium from waste batteries, or black mass, as they're called, from batteries. So that's something we have to do. We have to recover the lithium from spent batteries, not only because of the lithium, but because of waste material, avoiding waste materials in nature, of course. So it's something we hope that will be a success when it comes to the industry, that they have to recover this. If you look at the whiteware industry, we have a system, at least in Norway, and I think in many Western countries at least, where you free of charge, the companies will take, or you can return your whiteware after it's been used when you want to buy something new, and then it's put apart, that's taken apart, and as many materials as possible are recovered actually from that. And I think this is the way we have to go with all our things. When we
really great.
When we come back to CO2, which of course, if we look at oil and gas, one of the main things it's used for is plastic.
Yes.
All polymers in all kinds. And where do the polymers end up? Well, rivers, sea. It's washed up on the shore everywhere. It's terrible. It's really terrible. So if we could reduce actually the production of polymers, we should try to reduce it. That would reduce the demand for oil and gas, especially oil. And we have to take better care of the waste that we're producing.
Yeah, the whole petrochemical industry is there. It's based on all these materials, and most of the stuff is going into materials.
Yes.
So we have to think about that, how to convert energy into materials and materials into energy. Anyhow, I will go very deep into it. So I'll stop it here because it's really near to my heart topic. Then I want to ask you that if you could go back, although you have done another PhD right now, but even then I will ask that if you could go back to when you started your research as a young Hallvard, is there anything you would study different or focus more on?
But this is a very difficult question because times change.
Yeah.
And if I were to start again now, but if you're asking me starting again at the same time as when I started, I think I would probably have done more or less the same thing. But a lot of things are coincidental. I mean, a little bit of a chance where you end up actually. But if I were to start today, I would definitely start. Maybe I would do chemical engineering, but also maybe medical engineering. That's one of the nice things we also had during the last years. I don't know if you're aware of it, but during the Corona pandemic, then we developed a testing system as a collaboration between the biochemistry or the medicine, and the chemical engineering department. It was developed within a few weeks actually.
Wow.
By this collaboration, and could be taken into operation very rapidly. And it was a very cheap and very efficient way of testing whether you had corona or not. So this is one of the, I would say, major feats that the department has been able to perform during the last 10-15 years.
Very
So
nice.
it's very, very nice.
Yeah, I do remember our teacher, Wilhelm Glom. He was working on something absorption of
Mm,
medicine, and he was working with polymers, and
mm.
then things like that. Maybe he might have done something in that.
Yeah,
I'm
it was based on these small particles,
yeah.
mm.
He,
Impregnated small particles. Mm.
really, really, I'm really happy to know. I'm proud of my university and my department and my teachers and everything. Okay, the next question is that what inspired you to pursue a career in chemical engineering, and what kept you passionate about research and teaching? You might have gone to industry, and
Mm.
you might have done so many other things, but why teaching and research particularly? First of all, why chemical engineering, and then why teaching and research?
Why chemical engineering? That's a very good question. Because when I went to high school, when I finished there in '66, well, I wasn't quite sure what I wanted to do. I had plans to be a medical doctor,
Okay.
but then my final marks from from high school were not good enough.
Okay.
So a friend of mine and myself, we went to the Australian embassy, or we wrote to the Australian embassy in Stockholm and asked for immigration papers.
Oh.
Wanted to go to Australia
Okay.
to go into medical science. But then of course, we applied at NTH, as it was called at that time,
Okay.
and we were admitted into the chemistry program. So I started with chemistry. I did a little bit, or a bit of chemistry, I would say, in high school. So I was interested in chemistry, biology, things like that. And after 2 years at NTH, you have to choose which way you want to, or had to choose at that time. I think you still have, which way you wanted to go. So I opted for biochemistry.
Okay.
I wanted to go into biochemistry. But after about two months with theoretical chemistry, I found out this was not for me.
Like I never liked chemistry, although I'm chemical engineer, but I never
So,
liked chemistry.
yeah. So I went
I
back,
was,
or went to chemical engineering then,
I
and
was,
I've never regretted that, actually.
but
Never. Yeah. But I think, as for many people, it's a bit of chance. I mean, you really don't know exactly where you want to go.
my father
And
chose for me chemical engineering. Please
yeah,
go this way. I don't like chemistry. He said, no, I know your marks are telling that you
yeah,
like chemistry. Actually, I got good marks in chemistry in FSC. So he said you should go for chemical engineering.
yeah. Yeah, it's a nice field, and the nice thing about chemical engineering is it's so broad.
It is.
It's an extremely broad topic. You can use what you learn there in so many areas. So and that's very, very nice.
From digestion, from cooking, from
Mm.
human body to large industries, everywhere is chemical engineering.
Yes.
That is true. Okay, then I must ask another question. Um, you have mentored many students. One of them is me as well, over the years and again. And what qualities do you think that make an outstanding researcher or a PhD student?
Uh, I think maybe it was Einstein, or somebody else said that
Curiosity?
genius is 1%. What is called ability, the 99% precipitate, or transpiration, that
Yeah.
you're really sweating. And I think the thing here is persistence. That well, first of all, you have to have interest in what you're doing. and you have to have some persistence, that you don't give up even if things really don't turn out the way you hope they would turn out immediately. So then you don't give up. That's a main thing, because things will always go wrong.
Of course.
I mean, there's no way that everything will go right. It will always go wrong. And I think that might be one of the problems that the younger generation nowadays have, is that
Actually, I have a follow-up question. You are already answering. The question is, since you are answering, but I must ask first the question so that it looks that you are answering me. That what is one piece of advice you always give to young engineers and scientists entering this field? So you are.
Well, I don't think I have any special advice that I always give. It's mainly that they shouldn't give up, even if things do not work out the way they should. If you do modeling, you do programming, and you do modeling, and you make a nice program for something you want to investigate, and then it works the first time. Then you know that there are at least 2 errors in your program, and they cancel out each other.
Yeah.
So there will always be misses. There will always be errors. There will always be mistakes that you do. And I think that, again, if you only look for the best, it will be very difficult to succeed. You have to look for the good. As an engineer, at least, this is maybe if you're in other fields, maybe you look for the best, but as an engineer, you should look for a solution that is good enough.
Yeah, that's true.
So not always go for the best, because then you'll be disappointed in yourself and in your surroundings.
During PhD, there are many experiments with wrong things. Things are not matching. Keeping moments and stress and what's happening. And Hallvard is there, no problem. It will be okay. It will be done. You had been, just for interest and to detract you from this very academic discussion, I want to add something. I'm really good palmist. I look at the hands. And when I look at your hands, the shape of your fingers and your thumb, it gives me someone who is an artist. I have never told you. I'm telling you this today. That your hands are, you are an engineer, but your hands are very artistic. And you know the art of science. You know the art of teaching. You can inspire people. You can look at what someone has, the quality. You can pinpoint that, you can encourage that, and you can mentor, you can guide, you can shape, you can frame people and their future. Hanna, in our own petty discussions, we used to say, she had been your student and I had been your student, and she was my co-supervisor with you. So we had discussions, and she used to say, when we are in Hallvard's room, in his office, when we are discussing something, everything looks fine, everything is understandable, it's nice, no problem. And the moment I leave his office, everything is gone. Yes, it happens. It happens. It's Hallvard.
That sounds bad.
He will make you do everything. I will not say that you are a lenient person and you will accept anything less than it should be. You will make me do which you expect me to do, but you will not do it forcefully. You will just do it slowly, with technically, with care, with concern, with passion, and you will get best out of me without knowing me that what you are doing.
Yeah.
I remember my autumn thesis when it went to you. It was all red with lots of things. And with your note, it really looks good. It's great. But when you will do all these things which I have done, I have suggested, it will be the best. And I just forgot that it was all red. No worries. I just did whatever you said, and then it was best. This is how you work. And it's a God-gifted quality. I can see it from your hands, from the shape of your hands. I knew it, that you are master of this art.
Okay. Okay, I don't know what to say.
Let me tell you what I am good at. You are good at transport phenomena and CO2 capture, but I have my own knowledge as well.
Okay.
Okay, yeah, it was just for fun. And of course, I mean whatever I said, I mean that, but the chemistry part was fun. And the next question is, can you share some memorable moment, or perhaps a breakthrough or a challenge from your time as a professor at NTNU?
I mean, I wouldn't break through. These are big words, So, I mean, life and developments are made up of small steps. That's what I think. That you take one step at a time, and hopefully in the right direction, so that things improve. So I don't think I've experienced myself any breakthroughs that I would like to, or that I would like to call a breakthrough. That's not the way I see it. It's there have been small steps all along, and as I said, hopeful in the right direction. So it's that's how it seems to me, at least.
Yeah, let me explain it. Yeah, persistent. I do remember you coming always on time for our early in the morning meetings, most of the time at 8 o'clock, and you are there, always using stairs. Never. Are you still using stairs, or
Yes,
you're still using stairs?
yes.
Okay.
I need to.
Always using stairs and always on time and ready with your lectures and everything. Whatever we have sent you, you have gone through that. You have suggestions for those things. And I must say that if there were any other person except Hallvard, I would not be able to complete my PhD, at least, especially with lots of children, 3 children, 2 doing PhD, and then the third one. And I finished everything. It was due to you and Hannah. Credit goes to you guys. That you people made me work with all those things coming through my life, especially the death of my mother, and you had been very kind to me. You never asked me, Shalad, why are you not coming? For the whole month I stayed home, and you never asked me that where are you, and what are you doing? So your kindness and the way you made us work, that's marvelous. And I am saying all this from core of my heart. I need nothing from you right now, but let me express. This is how it was.
Yeah.
So
Thank you.
Consistent. That's why you are Hallvard. Hallvard. That is good. Okay, and many students of you would be listening to this. Mayuri.
Mayuri, yeah. I had a bit contact with her.
She told
not the last year, I think, but before that, yeah. She's doing very well, it seems.
Yeah, she is. She is. And she would be listening. If not right now, later on, she asked me, will it be recorded? I said, yes, it will be. And she will be listening to it.
Yes. It's it's in the middle of the night for her.
Yeah. For her, it's middle of night. That's true. Okay, then it's something personal between you, me, and my husband. Since both of us, we had been your students. Means we had privilege, me and Naveed, to be your students in transport phenomena, and I with gas cleaning, and then PhD, and Naveed as researcher working with you. How do you remember me as a student?
I, of course, with Navid, it was, as you say, a researcher over a more limited time span. With you, it was first a master thesis and the PhD. And the way I remember is that you always worked, as I said, you had persistence. Because, I mean, what you tasks that you had taken on were not easy. Remember the carbonate systems, they're not easy, and but you had persistence and you performed so well. Even as you say, you had 3 children, your mother died, and you had all these other things outside of your studies. You performed really well. So I'm glad that and I'm pretty sure that now when you're a teacher, as I understand, you're you're an excellent teacher. I'm pretty sure about that, because
Thank you.
you know how to I mean, work with people, and you know your subjects. So I think you know how to how to actually get the students to work and to learn. You know how to teach. So I'm very happy with the time we had together. That I must say.
Thank you.
But it's been some years now.
Ah, who cares?
Who cares?
Um,
Yeah. When
that's
did you finish? Actually, was it in 12,
yeah,
13,
40. Yeah,
14? Yeah, 14. Yeah.
but I had been working till 2015.
Yeah. Yes, you worked a little bit afterwards. That's true.
Yeah, till June 2015, until we went back to Pakistan, and then there are so many stories which I never told you.
Yeah.
Okay, so
Yeah.
thank you, Hallvard. I'm really overwhelmed by all this, listening something from your teacher, who is your teacher, and I'm a person who is very blunt and blatant. I either love my teachers or I hate my teachers. I have
Okay.
nothing in between. Yeah, I have nothing in between. So because for me, teachers are very ideal entities, personalities. Uh,
Mhm.
they should be either loved or rejected. So you are the loved one. And from a loved one teacher, from a teacher who is loved one, to
Mm.
have such nice remarks after years. You made my day. It's Valentine's Day. We should remember. That's why I'm wearing red sweater.
Mhm.
Okay. Hallvard, yes, Naveed. He had been working with you with the
Yes.
project.
Also, yes. Also did a very good job over the relatively short while that he had the
Yeah, it
possibility
was
of
for
working
2
there.
years. It was
Two
2 years.
2 years. Yeah. So it was a relatively short period, but it did a very nice job. I would say very nice job. So, but he now works with Clarion.
Yeah.
That's good. Yeah.
He's a practical person.
Yes.
He's not. I am the difference. The major difference between me and Naveed is that I'm a theoretical one,
Mhm.
go into theoretical details, and he has nothing to do with theory. That's why he really had tough time with passing transport phenomena.
Mm-mm.
He attempted several
Yeah,
times.
yeah.
I'm going to tell you a joke. The joke is that we had transport phenomena in our autumn in 2009, the very first semester,
Mm-mm.
and we were already late due to visa problem of our daughter, and we had already missed so many things and lectures, and when there was a exam of transport phenomena, it was really tough. It was tough,
Mm.
and most of people, they could not pass, and I got B in that.
Mhm.
And we always had our carbon papers underneath the original one, and we had our copies with ourselves.
Mm.
So when after 1 or 2 years, all the students like Rafiq and Naveed and Saeed and they all
Yeah.
of them, yeah, all of them, they were preparing and they were at our home and they had their notes, and uh, between those notes there was my soul written as notes. And Naveed, he opened and he looked at all the answers and he said, you were not able to answer even a single question, means you did not reach the final answer. Then why the hell Hallvard gave you B in it?
Yeah. Well, it depends what you mean by an answer. I mean,
Now you tell, please. This is not
yeah.
my
But
this is not my question. It's Naveed's question.
yeah.
I was not able to give you the final answer in, as he says, in the whole,
In numbers.
yeah, in
In
numbers.
numbers,
Yeah,
but
in numbers.
numbers are not in an exam, at least not
Yeah.
important. It's the understanding, the underlying understanding that's important.
Yeah, so he
So
said, yes, well, why the hell you got me? Because you also, but I knew that you gave me. This is what I said, that you were able to understand what you were able to understand our image. It's always hard, when it comes to communication and everything. The hardest thing on earth is to tell you that what is the image in my mind, to communicate.
mm,
And you were able to grasp that communication, either in terms of equations or in discussion or whatever is said. You were able to catch that. This is God gifted quality in you. God bless you for that. Yeah, that is
okay.
true. That is true.
Oh, okay.
Okay, then looking back at our time together, is there any piece of advice or lesson you hope we carry forward in our careers?
Oh, what you're asking is really difficult to answer, because what advice should I give you now?
Yes, yes, I
You're
always
you're a grown up person. You know best what to do yourself. I think that may be the best advice I can give you. You think for yourself and do what you think is right.
yeah, that's true. And I always
So
do what I think is right.
hmm.
I'm not a person who will be swayed away by anyone else's advices. No.
No, and I know that you always look for facts. You look for the facts behind things, and I think that's also very important, especially now when newspapers even are full of, well, I would say, light things. The journalists, they write about things they really don't know about, and there are so many, I would say, errors and half truths in what is written. And if you go to the social media, where I haven't been really, but I'm hearing that there you get anything,
That's true.
that just opinions.
Yes, just to
Uh,
be honest.
yes.
And you are actually spot on, Hallvard. Uh, half truths are more dangerous than
Mm.
blatant lies, because
Yes.
once they are mixed, people start believing them.
Mm.
And when you mix half truth and half lie, then you make an amalgam, which is really, really dangerous. And you will never be able to find that where is the truth and where is from where the lie starts,
Mm.
until and unless you are very keen and you have an eagle's eye to look into the matter, that what
Mm.
is actually behind
Mm.
what is behind the scene.
Yeah.
And that is true.
Mm.
Perfect. I will think about it. I will.
I know you will. I know you will.
I have noted here with my dupatta. Dupatta, we call our
Okay.
shawl in Urdu. So I
Okay.
have noted here.
Okay.
So I will be. Okay, Hallvard. Actually, it's about 90 minutes. We are on.
Oh yes, we have used more than the hour you said.
Yeah, yeah. You're so nice and kind. We can talk more, but final question, which is written, then we will have some informal conversation as well. That after an incredible career, which I think you have, I admire it, or and that career of research and teaching and technology and everything. What legacy you are leaving? Your footprints, your digital, your
I think what I'm actually most proud of is that I have tutored, I don't know how many master students, maybe 150, something like that, and 37 PhD students.
Mhm.
And in a sense, you are my legacy. So because I see that, as far as I know, at least all of the PhD students, they're in meaningful jobs, doing a good job in whatever field or whatever industry or governmental organization, teaching, whatever they're doing a good job. So that's what I'm most happy about, that I managed to have so many PhD students that are now sort of continuing work in good fields, in very important fields. So, of course, in research, as I said, it's step by step, and working together with Sintef, with Hanna, with all the group. We have managed to do things, but I think that PhD students, it's really what I'm most happy about.
Yes, you have us. We are your legacy.
Mm.
And whatever we learned from you, it is within us. I always looked at you. If Hallward were here, what would he do? I learned passion and patience and care and human values and simplicity. I do remember um that you coming to university on your cycle and wearing that stripped sweater for years and years and ages. You never thought about it that should I, and you have just a suit uh, just hang in your office, and in emergency if you have to wear, you will wear it. Okay, I'm ready for that. Such a simple person. You made life
Mm.
of many when it comes to economics and the projects you had been dealing with. There were millions of crores involved, but you had been so simple person with that car you never changed, that sweater you never thought that it should be changed, the same boots, the shoes, and the simple person, but always ready to give knowledge, always ready
Mm.
to accommodate us. And I do remember that when I was doing my master's, you knew that I was on HEC scholarship, and you were the person who used to say that you should go for funding from our projects and
Mm.
NTNU, because it's a very small amount. And I said, no, I don't care. But you were the person who insisted that I should apply for the projects and I should apply for the PhD. And
Mm.
we got that, and you were enthusiastic and you were happy. You were the person who got that, who grabbed that for me by saying that we will apply this. And
Mm.
but in your own life, you I found you a very simple, down to earth person, taking stairs, after the cake breaks on the Fridays, just cleaning and with your hands, just taking care of the rest of the cake around, tidying up everything, putting things in dishwasher, making coffees for others. And during our conferences, just being very friendly and caring. You are not only a teacher. I learned life from you, Hallvard. That is true.
Hmm. Yeah, okay. Yeah.
Yes,
That's, yeah. I wasn't aware of that, but okay. Mm.
I never
It's
told you.
nice.
I,
No, you never. Not until now. No. Mm.
I never told you. That's why you didn't know. But I have
Mm.
learned a lot from you. I do remember that we used to bake cakes on Fridays,
Mm.
and
Yes.
there were sometimes very weird taste things. Sometimes, but you always tested, finished till end. You never said that it's not good in taste. You never left anything in the plate. Everything placed back, neat, clean, and ready to do whatever, and ready to help everyone coming to you. So it's not only being learning transport phenomena or a PhD. There could be any teacher
Mm.
who cares, but the person who can be idealized to learn life, you are that person for me. And please, that's
you're, you're sort of, yeah, embarrassing me a little bit
no,
now. Well,
that is true. That is true. I'm
yeah.
just speaking my heart, and you know, I need nothing from you right now.
Mm.
But uh, this is how I feel, and I'm always obliged. And you know, one more thing which we had been talking about. Sometimes I popped up in your office. Okay, Hallvard, this is Dadu. So, yeah, you did a marvelous job. Yeah, by grace of Allah, I used to say, by grace of Allah, I have done that. He said, it's you who has done. I said, no, it's Allah who made me do this.
Mm.
This was
I think we have a slightly different view of life and whatever.
even even then,
Yeah.
even then, this is since I am saying so many good things about you. That's why I wanted to tell you conflict as well. That I used to
Mm.
say that Allah made me do this. This is you who has done.
Yeah.
This was the only difference. Otherwise, everything. I always look towards you. And Albert, thank you very much. I cannot express my feelings that how happy, overwhelmed I am to see you here, and you had been so kind to give this interview. It will be a digital footprint. It will be one of the most wonderful things on my YouTube channel. I don't know whether it will grow, it will be here, but it will remain there.
Okay. So have you had this YouTube channel for a long time?
It's about 3 years, but I take
Okay. Yeah.
it occasionally. I take it occasionally whenever I get time. But
Mm.
now I have started these regular streamings with my friends.
Okay.
Yeah, so I'm doing this, but this is first time that it's in English. Otherwise, it's in Urdu always.
Okay.
Yeah,
That would have been difficult for me.
yeah. Of course, you cannot. Maybe sometimes if I will learn Norsk, then I will say Hallvard. Now in Norsk, I am ready.
Yes, that would be very nice.
That will be very nice.
So then you can come back when when you're ready for that.
Yeah, I will do.
I'd
I
be
will.
happy. I'd be happy. Okay,
Okay,
but thank you, Srala. It's
yeah,
been very
you
nice.
can conclude.
Mm.
How did you feel about it, and conclusion about all our conversation?
No, has been nice.
Mm.
It's been a good conversation. So your cold is still around a little bit? You still feel the cold?
Yeah,
Mm.
it is. It is. I
Mm.
was suffering from fever, but much better now.
You're much better, yeah.
Yeah,
Yeah.
but still there's problem.
Okay.
Hallvard, thank you very much.
Thank you. Thank you.
God bless you.
Thank you.
Have a nice time. We'll see you.
Yeah. Okay. Bye-bye.
Bye.
Bye.
Allah. I will speak something in Urdu. یہ
Mm.
میرے استاد ہالورڈ ایف سوینسن، ان کے لیے میں نے جو کچھ بھی کہا آئی ریئلی مین اٹ. یہ وہ شخصیت ہے جنہوں نے شیلا گوندل کو ڈاکٹر شیلا گوندل بنایا. اگر یہ میری زندگی میں نہ ہوتے تو شاید تھوڑی ڈفرینٹ ہوتی تو صحیح، لیکن کچھ اور ہوتی. تو اللہ تعالیٰ ان کو ہمیشہ خوش رکھے، شاد رکھے، آباد رکھے، انہیں لمبی زندگی دے، اور یہ ہمیشہ خوش باش رہیں. اور ان کی لیگیسی ہے ہم سارے اسٹوڈنٹس. اس کے ساتھ ہی میں وہ الفاظ کہوں گی جو ہمیشہ کہتی ہوں، اپنا اور اپنے چاہنے والوں کا اور اپنے ارد گرد کے لوگوں کا ڈھیر سارا خیال رکھیں، اپنے ماحول کا خیال رکھیں، اور ہمیں اجازت دیں. ہالوڈ کا ایک دفعہ پھر شکریہ. تھینک یو ویری مچ. اللہ حافظ. Shami, it was marvelous, yaar.